Friday.
Okay.
We usually don't have school.
You normally don't have school on Friday? Me either. It's a good thing about being full-time. I pick my own schedule. I don't pick Friday for myself. But I did this time. So let's get back into 8.5. We got up to this point here. The weirdness that is the absolute value. And we realized after some discussion that it's not as straightforward as we thought. Because mathematically, it does two different things. In English, it does the same thing, it makes everything positive. But if it's already positive, it leaves it alone. So if the number inside is at least 0, it'll just leave it alone, right? So the absolute value, what will it do to x? Not a damn thing. That will equal that, if this is true. So does that make sense the way I've written that? I don't know if you guys have ever seen, anybody know what the name of this thing is when I write a function 2 different ways, or 3 different ways, or 18 different ways? It's called a piecewise function. I don't know if you guys have ever heard of that. That makes sense. It's in pieces. I don't know why I put this word wise on there, to be honest. Right? It reminds me of Pennywise from It. The elf flute. But anyway, yeah, has anybody else got nightmares from the elf flute? Yeah. If it's negative, what does it do? What does it mathematically do to the number if the number that's in there is negative? Multiplies by a negative. To change it to a positive, right? So when you see this, though, students are like, no, the absolute value can't be negative. You're right. So if x is negative, what's a negative number times a negative? Positive. There you go. So it's positive. If it's already positive, it leaves it alone. If it's negative, it makes it positive by multiplying it by a negative. Okay. Maybe. It's a very evil little subversive little function, right? And this, see how many cases there are? There are 2 cases. So in equations and inequalities, when I have absolute values, there will always be 2 cases to consider. All right.
When it's just x.
Yeah, when there's any variable expressions inside.
Any variable expressions.
Exactly. So this is just x. Now when I put other stuff in there, that's why it leads to 2 different cases. So let me just really quickly remind you. Actually, I tell you what, I think I've just made a decision, an executive decision. Let's hold off on section 9.1 until the next test. All right? So you only have to do homework until 8.5. Because I don't even feel like rushing through this, because it's a little weird. Especially in inequalities, you guys have probably never seen how absolute values work in inequalities. I don't even know if you guys have ever seen how absolute values work in equations either. So let's not rush, Jeff. All right.
So just 7 and 8 will be on the test?
Through 8.5.
Yeah, all 7.
Yeah. So it's just chapter 1 through 8. That's it. All right. So let's say, now what I'm about to do, I'm going to show you visually the idea behind this. And you can't always do it. When I make this a little more disgusting in there, you can't do what I'm about to do easily. So I'd rather have a mathematical way to do it instead of a visual way to do it, right? But here's the idea behind this. Again, absolute values are based on what physical concept? Distance, right? That's why they always come out positive. I can't say you're negative 4 feet away. I don't care if I turn, you're not negative 4 feet away from me. You are 4 feet away from me, right? The whole Quay thing came about. So I want the numbers whose distance from 2 is 7. That would be the answers. I want to put a number here whose distance from 2 is 7. So if I go this way,
-5.
You're neat. All right, well, okay. You're like, I don't want to do what you just said, Jeff. If I go this way, it's -5. Is that 7 away from 2?
Yeah.
Of course it is, right? And if I go that way, it's 9. So the answers to this equation have got to be -5 and 9. So any math we do to it, better come up with those numbers or screw the math, right? Unfortunately for you, we're not going to screw the math. The math is good. Math is strong. So that's the visual of, so these are the answers, because those are the numbers that are 7 away from 2. Yes, ma'am?
And would you just write out as x equals -5,
Yeah.
x equals 9?
X
Or would
equals
you put it
-5, 9.
There's points. Okay, so just that.
Yeah, they're not really points, because it's not 2-dimensional, thankfully. Right? You don't want two-dimensional absolute values. Trust me. Oh, real quick. So what does this look like mathematically? So this is the visual. What's the math way to do this?
Just plus 2 on both sides.
No, can't do that.
You write two equations.
Good. I can't break into the absolute values. Absolute values, where are they in PEMDAS? What do they look like? What do they look like? Parentheses that have been straightened out, right? They went to that scared straight thing. Parentheses, take it, oh, good. Sorry. So they're actually absolute values are the same position in order operations as parentheses. Does that make sense? So if I saw it inside of a problem like you will, I will actually do this to you. I'll give you a problem that has absolute values in it that's in order operations. You do the inside and then you do the absolute value. They come first. They're parenthesis level, right? I like it. So the inside of them comes first. So what could I replace this with? I really want this to make sense. We don't do a math. Let me see. I don't do something to both sides immediately. I rewrite the meaning behind this. So I don't do algebra to it. I use an idea. So what could I replace x minus 2 with to make this true? Well, the absolute value of what is 7? This could be what?
-7.
Okay, it could be -7.
Could be 9.
Or it could be... No, come on now.
7, right?
The absolute value of what is 7. So what can I replace this with? I could make this equal -7, and then this is true, right? Mm-hmm. Or I could replace this with 7, and then this is true.
And you solve both.
And then you solve both.
And that's how you get the...
And that's why you get two sides, right? It's got to be two cases for an absolute value. So x equals -5, thank God. Or x equals 9, thank God. So both ways of looking at it worked. Right, so there's always multiple ways to look at any math problem. And the higher up you get, you can actually translate a whole problem into a geometrical problem and then bring it back. And sometimes it's easier to do it visually, and sometimes it ain't. All right. So that's the basic idea behind what we're going to do with absolute values. Is everybody cool with that so far? Do you guys understand what's going on?
Yeah.
So anytime you see an absolute value in an equation or an inequality, you must do two cases. For some reason, people just they see this, and then they go, add 2, x equals 9. Where do the absolute values go? How did you do that? The absolute values do nothing? No, they got to do something. So don't do that. Bad. Okay, so let's look at a more complicated problem, because they're not going to be that easy. Slightly more complicated. So what if I had... Sure. Now please, thankfully I computer generate my tests. I remember when I first went to college, I was a TA and there was these ditto machines. The teachers would write their tests and then I would crank this ditto machine and make copies of it. It makes it sound like I'm 80 years old, but oh well. We still had the freaking ditto machine in my little tiny, poor little college I went to. And, I'd sniff them and you get a little high. But you don't want me writing my own tests. But it's not 14x minus 71, right? This is absolute value of 4x minus 7, and it'll be really clear when the computer does it. It'll be thin, long, doesn't look like a 1 at all. Anyway, okay. So what's the first step here?
Set up with 4x minus 7.
Yeah, so either...
Equals 11.
Good, so one case is, if that's already 11, it's got to be true. Or, if that's the case, if I replace this with -11, what's the absolute value of -11?
11.
It's also 11. So both of the answers to both of these they'll both make this equation work. That's the idea. That's why this idea works. So then I get add 7 divided by 4.
Add 7 divided.
Add 7. Divide by 4, right?
Oh, yeah, 18.
Yeah, 18 over 4. So 9 halves.
92. Yeah.
Is that cool?
All right.
Add 7. Divide by 4.
-1.
-1. Alright, cool. And you guys can solve those.
Easy.
No big deal. I like it. You can check it like always. You plug a 9 halves in. Let's try to check it. Check it. What's 4 times 9 halves? What's nice here? 4 times 9 halves?
26 over 2.
Oh, 1. No, 2. 1.
18 minus 7 is 11. Which absolute value of 11 is 11. Right? I'm just checking it. Just throwing it in there. See if it works. What about -1? 4 times -1 minus 7. What's 4 times -1 minus 7? Negative last. We got -11. Whatever. Check. So they both work. Sweet. So one answer is that way, and the other answer is that way. Right? Visual. Kick ass. I like that. Some of you guys are bored. You're like, come on, Jeff, step it up.
What about if it was, wait, can I give you an equation?
Say again?
Can I give you an equation?
Sure.
What about if it was like 1 take away 2 over 3 x equals 0? And it was in that little
Like
line
this here,
thing.
right?
Yeah, and then it's all equal to 0.
Ooh, I like it. Kick ass. Well, let's try it. Let's try it. Now watch. Before I even talk about concept, let's just apply the process. The process has to work. Right?
Mm-hmm.
But there will be a situation, and then we'll talk about the concept, and then we'll talk about what could I put over there so I get no answers. There's something obviously that
Wait,
hopefully...
so we're trying to find a no answer?
No.
Oh,
No. Okay. So there are equations that exist, and we know this, that have no solution, right? Same thing happens with absolute values. In fact, what can an absolute value not equal? So if I gave you an equation that looked like this, x, it doesn't matter. 7x minus 48 equals -2. You don't have to do a damn thing. You could do the 2 cases. The 2 cases will give you 2 answers. Neither one of them will work. Right? Because there's no way absolute value equals a negative, so this would be no solution. You don't have to do any work. If you do work, you might forget that there's no solution. You might say, circle your answers and you're wrong. Oh shit. Yes?
What about, can't you like set it up though differently and like have the answer be negative, then the 2 lines, 7x take away 48, and then equals the -2? You get what I'm saying?
Do it
Because
again.
I remember you taught us that way, where you said, okay, say if it was like a 5 in the lines equals -1 or whatever, but can't you put like the negative sign or -5?
Put a -1 times -1, the whole absolute value.
Sure,
Or-
then you'll have the negative of this. Are you saying to do
Yeah,
this?
like that.
Like that?
Yeah, and then but that would equal the negative over there, wouldn't it?
Alright, but this is saying the negative of absolute value is positive. Is that possible? No. It's
No.
still not possible.
I'm saying that it would equal -2 though. Wouldn't that be possible?
Oh. So don't, you're saying make a new equation.
Yeah,
You're not
can't
saying
you-
do something. Okay, so
can't you
if
do that?
this was the problem, not that, if this was the problem,
Fine.
then you kill the negatives and then you're fine. Then you set up your 2 cases. Yeah,
Oh.
I like it. Right, you divide both sides by negatives so the negatives go away. Right?
Okay, that
Alright.
makes sense.
So I lost you on the first one. So you're saying it's no solution. Why is it no solution?
Because what would you put in here to make the answer -2? Let me not even. There's no. You can now. It's totally up to you. Give me a number that I put in there that makes the answer -2. So see, I really want you to understand. When we solve an equation, we're saying when I solve this equation, we came up with numbers that I can put in place of x that makes this a number that becomes this, and that's how we checked it, right? I like it. So, in order for there to be an answer, this has to be able to become a number that makes this work. And what could this become to make this work? 11 or -11, right? So now I'm saying, whatever's in here, whatever I put in there, why did I put 7x minus 48? Because I just put something. It could be anything. What would you put in here to make it come out to be -2? There ain't a damn thing, right? Do you guys understand?
Mm-hmm.
So, what's the absolute value of what is -2? Nothing. So it doesn't matter what I try to make x equal. it can't make this become a number that works because there are no numbers
How
that
did you do it
work.
on that one? It's the same
Because
problem.
it was a positive 11.
So anytime you see it where it's equals is a negative, it'll never work on the absolute.
Unless,
value.
like the good example was, if there's a negative there, they kill each other.
So that if it's equal as a negative,
Yeah.
and there's not the negative on the outside, it's always be.
We're working our way. Give me a second. Let's do this one, and then I'm going to show you what if there's more going on in the equation, which is kind of like what you're asking. You start to put more and more in the equation. Yeah, we'll get there. But this one, real quick, it's still the same idea. The funny thing is, well, what's one case going to be? Either what? Don't freak out. What do we do here? We said either this is 11 or this is negative 11.
So
All right,
it'd be
so
1 take
either
away
1 minus 2/3 x equals
0.
0, or 1 minus 2/3 x equals negative 0, which is the
still
same
the
thing.
same.
That's
Okay.
why you're going to get one answer here. There's only one way to make an absolute value 0. That is to put a what into it? A 0. Right? How many ways can what can I put in here to make it 1? How many things can I put in here and make it become 1? How many things could I could put a 1 in there? Or a negative. There's 2 things I could put in there, right? How many ways can I make it come out to be 0?
Negative 0, 0.
What's negative 0? So there's only one number I can put in there,
Oh,
0.
the x would.
Be 0.
It wouldn't that. No, that. Yeah.
Well, now
the
I
x
just solved
would
this.
be
No big deal.
0?
Right? No big deal. No. Because 1 minus 0 is not 0. If you wanted to, how do you kill the fraction if you wanted to kill the fraction?
Well, I was going to say make positive.
Multiply by
2/3.
3. Multiply by the denominator. I get
Still get 0.
3 minus 2x equals 0. Solve for x. 3 equals 2x. X equals 3 halves. Bam. You guys are expecting it to be hard. So once you apply the idea of the section we're in, it becomes an equation. You solve the equation like you always do.
Sorry, I missed that. The times the.
Yeah,
Where's
just to
that
kill the
three
fraction.
Oh, from right there? Okay.
Just to kill the fraction and multiply by the LCD, which is just 3. There's only one fraction, right? All right. The weird part about this problem should have been 0. But the minute you start to set up your cases, you realize I'm writing the same equation twice. I'm just going to solve it once, right? Negative 0 is 0, right? All right. So notice something. If this number is bigger than 0, you'll get 2 answers. If this number is 0, you get 1 answer. If this number is negative, you'll get no answers. It's crazy. But do you have to know that going in? Not really. Not really. You don't have to remember that. You don't have to memorize that. All right. So here comes the real thing that's going to help us figure out all the little side stuff that was asked. Every time I've done a problem so far, it's been the simplest case, to be honest. I have an absolute value equals a number. So what if I have this? What do you got, Jeff? I don't know, man. Sure.
You subtract 3 from both sides first.
You gotta isolate the absolute value. I like it. Because everything we've built is when I have an absolute value equals a number, I know what to do. I can set up my 2 cases. Is that what I have now? No, I get that stupid 3's in my way. Well, then move it. Get it out of the way. Subtract 3 first. So then you get absolute value 5x minus 2 equals 8. And now you can set up your 2 cases, because now it's in the right form. So think about it real quick. What plus 3 is 11? 8. So this thing has to be 8. That's what that says. This thing has to be 8. How do I make that 8? Well, I can make the inside 8, or I can make the inside negative 8. Right? So I've got to get that 3 out of the way so I can really isolate what this has to do. What does the absolute value piece have to do?
Well, I just had a quick question about the subtraction method, because say if it was like, say if the 11 was a 2, so you subtracted 3, so now the answer is negative.
Real quick. Hold on. Let's finish this one out.
Okay.
Like I was hanging. Now it's easy, right? Should be easy, maybe?
And do it.
What are the 2 situations?
5x minus 2 equals 8.
8.
And then negative 8.
Or 5x minus 2 equals negative 8. So add 2, divide by 5, you get
4.
no.
You get
2, right? You get 10 divided by 5 is 2. You can show yourself the steps. Add 2, you get negative 6. Divide by 5, you get negative 6/5. Bam. Sometimes people forget, I almost don't want to say this, but the fact that this answer is negative doesn't mean it has to be thrown out. You see why somebody might think that? They're like, there's absolute values. It can't be negative. No, this is the inside of the absolute value. I can put negative numbers inside all day long. It just can't equal a negative. Right? So don't throw these poor little dudes out. Yes?
When you're writing out a fraction and it's negative, does it matter where you put the negative sign?
Convention says either on top or out front.
Okay.
If you write like this, technically you're right, but conventionally you're wrong, because it's easy to lose the negative if it's down there, right? So write it like one of these to us. Cool. I like it. I like it a lot. All right. So here we go. Here's the ultimate freakiness for equations, anyway, and then we'll get to inequalities. And for some reason, I'm going to bring restraining orders into math when we get to inequalities, just for a little teaser.
Professor?
Yes, sir.
On the last one. Right
Oh,
here,
and I got to answer your question too. Don't let me forget.
were you right there? 3 times that? Don't you times the 3? Don't you times the 2 like that as well?
Well, no, the 3 cancel with the 3, so it's not there anymore. Right, the 3 and the 3 cancel, so there's just a 2 left. Right. So that one we did earlier, like this.
Yeah.
If you distribute the 3, 3 times 1 is 3. 3 times 2/3 is 2. Because the 3's cancel.
Okay.
Yeah, or 3 times 2 is 6 divided by 3 is 2. Either way you do it, you get to 2. Yeah.
Okay, see, that's the point I have.
Okay. So what was your question?
Say if the 11 was a 2.
Yes, cool. I like it. Look at you going right where I was about to go anyway. All right, so why does that change anything? Well, what's the first step still?
Take away 3.
Got to isolate that absolute value, right? Get the part that has my variable in it by itself first, and that happens a lot in math. You want to get that isolated, right? So then you're going to attack it. I always call it like you're a tyrant, and you're isolating this element, and you're going to attack it. Subtract 3, subtract 3. So then I get absolute value 5 minus 2 equals?
-1.
-1.
Yeah, no solution.
No solution. Don't do any more work. No solution. If you do work, you get answers that are bogus, which sucks. Right? You got to kind of realize that, or you got to check all of your answers, right? So I'd rather always be on the lookout for when I get absolute value equals a negative. Okay, how are we doing so far? Yes, sir.
What if we have another variable on the outside of the absolute value?
We're not going to do those. That becomes really difficult because I almost don't want to write down, but I don't know if you guys can imagine. I mean, if I had something like this, you got too many things to take care of, because if x is -2, this is going to equal a negative. But if x is 3, then it's fine. You got a lot of cases going on. We're not going to see that. With square roots, we'll see that kind of thing, because then it's easier to just attack it. But absolute values is an idea, and that's just like, holy shit, there's too many things that could happen. So thank God I'm not going to do that to you. All right, how about this here? Let's see. How do you want this to come out, Jeff? I don't know, man. Yeah, I like it. Gruesome.
Did you say that the absolute value, parentheses come first and then absolute value? Is that what you're saying?
If it's a simplification problem where I can actually put these together.
If they were, okay.
I can't put these
I know
together.
you can't put
So
that.
we'll do a problem like that next. So you see, a problem with no x's in it, just simplification, right? Just 2 plus 7 divided by, well, you know,
I'm
that
trying
kind
to
of
see what the order of operations was.
Gotcha.
So, okay.
The funny thing with, I don't know if you, well, anyway, I won't go there. The thing I hope not to see anymore is for somebody to put a -3 here. That's the order of operations comes into an equation. I can't do 2 minus 5 because what's 5 involved in?
Times.
A multiplication. Multiplication would come before subtraction, right? But with equations, I can just go, well, let me just get rid of that then. Right? That's the thing with equations. I have another side that I can just shunt things over to that I don't like. So, I mean, I just gave it away, but what's the first step?
Minus 2.
Subtract 2. Because it's really, how would I solve this equation right here?
Minus 2.
Subtract 2 and then divide by -5. And you see what I did? That part I don't know. This part I don't know. I mean, you look at this thing, you're trying to get this thing by itself first. Yes?
So why is it -3 and why wouldn't it be no solution?
Wait, what's happening? No. All right, so this is the question. This is the equation that I'm trying to solve.
Right.
The -3 is not something I worked out. It is part of the equation. That is the equation that I'm trying to solve. Just like, where did that 11 come from? It was part of the equation. It's the equation they gave us, right?
But I thought if it was a negative, it's no solution.
If you end up, if the absolute value of something is a negative number, then you can stop and say no solution. Do I see that yet?
Oh, no.
I've got other stuff with my absolute value. Maybe if I get the other stuff out of the way, it won't be equal to negative anymore.
Okay.
So this is good. I'm glad you brought that up. That's the point when I'm doing this. Don't just stop because you see a negative sign there, right? You got to actually get the absolute value by itself
Okay, gotcha.
first. So again, subtract 2.
So I have a question. So if you didn't have 2 minus 5 in there, then that would be no solution, right? Because you wouldn't have anything else to do.
Well, if it was just this,
No, if you didn't have...
if it was like that,
Yeah.
totally. Because then the absolute value is by itself. I can see that it's trying to say it's equal to a negative. I know right there, no solution.
so-
I can't see it yet. I can't see what the absolute value is supposed to be.
So if you had just -5 in there, then you would have to solve it, right?
So if it divide by the
Yeah.
If I divide by -5, now that becomes positive.
Yeah.
It's fine. I keep going.
So it's by itself as long as nothing is to the left of the absolute value, right?
Well, nothing's on the outside of the absolute value.
Okay.
It's just the absolute value by itself. Like here, now I can see it's good to go.
Yeah.
Here, now I can see it's not good to go. Right? Okay, cool. All right. Good questions. This is good. So then subtract 2. How you get it? -5 times this mess.
3x minus 4 equals 1.
Careful.
It's -5.
-5.
So now we just divide by -5.
Divide by -5. Because again, it's just like this. -2 minus 2, -5x equals -5. -5 times something is -5. -5 times something is -5. What would I do next here? Divide by -5. I do the same thing. Divide to get the thing by itself that I don't know. I'm going to isolate my unknown thing, right?
Well, you say you're doing the whole thing, you're doing the absolute value, everything on there.
Well, I have to.
Yeah, you can't do that.
But I mean, does it actually affect this?
No.
Because it dies. Yeah.
Right.
Yeah. But I have to do the same thing to both sides, so I draw it underneath that whole side. But it dies immediately, so it's not around to affect this dude, right? And over there I get
1. So now you got to set it equal to 1 and -1. Right?
I like it. Kick ass. So let me write what we got so far. We got
3 minus 4x.
absolute value of 3 minus 4x equals 1. And real quick, let me just point this out. 2 minus 5 times what is -3? You should be able to just know that. 2 minus 5 is -3. So 2 minus 5 times, this would have to be 1 for this. Isn't that what we just figured out? So when you do algebraic steps, that's what algebra is doing for you, right? Because it's not always easy just go, it's going to be 7. No, so this algebra figures that out for you when I can't do it all in my head, right? That's what algebra is for. All right. So now, like you said, can I keep going?
Yeah.
Yes, now I've got absolute value. It has to be a positive 1. I know I can keep going.
Right.
Cool. 3 minus 4x equals
1.
1.
Or -1.
Kick ass. And then you get
So subtract 3. 4 equals -2.
So equals negative or positive 1/2.
good. Coolness, man. And then you can check those like always for play with again to see if it works. Real quick, one reason why I wanted to do this section before this, and now that I've let go of 9 for the moment, I feel a little bit freer. I can go back and talk about this. Because it's going to explain a little bit more why there's 2 answers here. Do y'all know, you all should know, even though we haven't talked about it, you know what an x squared looks like, right? Like if you graphed it, do you guys know what it looks like? What does it look like? Do you guys know? It looks like a little parabola. It's called a parabola. Some of you guys are like,
No. Can you show us that?
oh, what to what? No, don't worry about it. We're going to do that later. Right? But right now, how would I, if I have a function that I don't know what it looks like, go with me for a minute. If I have a function that I don't know what it looks like, how do I figure out what it looks like? I start to do what? What do I do to make a graph of it? Plug stuff in. And you should always plug in some negatives, 0, and some positives, just in case the function does different things. And we definitely have a function that does different things here, right? So if I make a little table of values, just go with me for a minute here. And you're all like, this is all we're doing this whole freaking semester. So if I plug in some negatives, 0, and some positives. These are my 5 go-to points to try. What's the absolute value of negative 2?
2.
Absolute value of 1?
1.
Absolute value of 0?
0.
Absolute value of 1?
1.
Absolute 2. Okay. So let's graph this. So I got, what points does this thing go through? Okay. Negative 2, 2. So where's that?
Left 2.
Yeah, left 2.
Or up
2.
2.
So it goes right here. It's always weird on the board. There. Negative 1, 1. 0, 0. 1, 1. 2, 2. Right? Because y equals x is a straight line. Right? Y equals x. It's kind of neat. Think about this. Y equals x is this. Is that cool? 0, 0, 1, 1, negative 1, negative 1. Y equals x. Y and x are the same. That's what y equals x looks like. When I do the absolute value, what cannot happen? My outputs can't be negative. So then this flips. Look, didn't see it? So it's coming in. I'm coming in. I'm coming in. Oh shit. You guys see that? Like why is a x squared? Why is it a u shape? Because it can't go negative either. So it comes into 0 and then it turns because it can't go negative. You can't square a real number and get negative, right? And it's curvy because it's not a first power. This is not curvy. It's a line because it is a first power. First powers are lines. But why does it turn? Because the absolute value doesn't let it go negative. It says you can't go negative. Oh shit, okay, I bet it. So normally it would be negative 1, maybe negative 1. But the absolute value of negative 1 shoots it up there. I like it. So what's my point here? When I say something like the absolute value of x equals 1, I want to know what inputs give me an output of 1. Well, what inputs give me an output of 1? 1 or negative 1. See that? It's because it comes back on itself. That's why there's 2 answers. Right? I like it. But if I try to make it equal 0, how many answers are there? 1. If I try to make it equal a negative number, there are no answers. There's no inputs that make any of those outputs. So that's the visual idea of solving this kind of an equation. Maybe. If you totally understood what we're doing here, though, you don't need that at all. But I just want to give you one more way to look at it. Okay. So let me give you guys a couple to try on your own without me doing it with you. Make sure we're all actually understanding what's going on. I'll start off nice. Look what I call nice.
That's nice.
Equals 2, sure. Yeah, okay, cool. Alright, so try those 2. Yep, exactly.
Professor. Right here. So these will cancel.
You can't. You can't bring that in there because you can't bring something out or put something into an absolute value unless you're really, really careful. So we haven't learned how to do that yet. So you can't do that. But you just. What's happening? Oh, you're just. Oh, I see. You're trying to do too much too early. You've got to write your two cases first, right? Because then your absolute values go away, and then you're allowed to do stuff to it all day. Yes, sure.
And then, do I do this one first?
No. Now you also have to subtract 7. Yeah. Because you could have put those together and then subtracted 11.
Okay.
Yeah.
Okay, and then I do.
Yeah. You almost always divide last. Yeah. But then we have more to do after that, of course.
Professor, to not do it. After I wrote down.
Well, you can take the absolute values away. See, that's number 1. See, the absolute values are in our way. Right? They're in our way. I want to be able to move the 8. I want to be able to do stuff, but I can't take them out.
Yes,
so when I rewrite it, I can take the absolute values away.
So I have to write the -2 as well, then I can take it away?
Yeah, one case equals 2, or the other case equals -2.
Okay.
Okay, that's true. I'm going to do the first couple steps on this guy. You know, you could multiply by 5 immediately, but notice how the 8 and the 2 are alike. You might as well get those together first. Right? Well, how are you going to do? You could have multiplied by 5. You should still end up with the same answer I'm about to get. I heard somebody say this earlier. How do you kill a fractional coefficient? How would you kill a 5? What would it do to both sides kill a 5? Multiply by 5. How would I kill the 2? Divide by 2. So I can just go ahead and multiply by its reciprocal, right? Because it's got an over 5, over 2, and it's got a 5 on top, right? So I'm going to multiply by -5 over 2, both sides. Doesn't that kill there? There, kill there.
Actually, is it possible for me? Actually, I just remove it from here and drop it to the other side and switch it. I mean, like I've done it exactly. So it is then 6 by 2, 6 by 5.
Oh, you divide -2 over 5.
I mean, immediately without.
Sure. Yeah. And the division by this is multiplication by its reciprocal. Yeah. That's why that's another reason why it works. Yes. Sounds like we did the same thing. So yes, you can do it. So then I get, on this side I get x equals, the negatives go away, 15, I like it. Yeah, 30 over 2 is 15. Yeah. Or,
20.
do the same thing there. And we have x
Yeah.
equals
25.
25. Yes, ma'am.
Is there a simpler way to do this problem? Or this is the
Do you have a suggestion? You sound like you might have a suggestion.
Well, I got the wrong answer. But
Uh-oh.
I thought you could do, you could multiply, and cut out the fraction.
Sure.
Okay,
All right,
multiply
so-
5
Yes, okay.
to the absolute value and 5 to the 2. But
Wait. What? Wait. So say again.
immediately, I
You
did-
can't immediately do that.
Okay,
Technically, you can't.
okay.
In actuality, you actually can, but I don't want you thinking you can just put anything you want to in and outside of an absolute value. You can't.
No, I was saying to eliminate the fractions. I multiplied the absolute value by 5 and the 2 by 5.
Sure, but again, since 5 is positive, you're actually allowed to bring it inside, but I don't want you guys thinking that that flexibility is more than it really is. You can't bring everything inside of a negative absolute value. You can't take everything outside of an absolute value. I need to get the absolute values out of the way before I can really do stuff to it. So, but if you rewrote your situations, what was it? Negative, yeah. And then multiply both sides by 5, yeah.
Oh, I see. You have to
But
figure
you
outside
should have.
of
It should have still worked. I mean, if you multiply this by 5, it should have still worked. You'll get 40 minus 2x equals 10, absolute value, and then you write your two cases. It should still work.
Okay, I cross-cancel the 5. Like when I multiply.
Yeah, sure.
I
But if you multiply by 5, isn't this 40 minus 2x, and then this side by 5 is 10?
So what I did was I crossed out the 5 on the outside and then the 5 at the bottom.
But then it didn't have a chance to go here.
Yeah,
5 times 8,
exactly.
the 5 doesn't
So I
cancel.
see where.
Yeah,
it
okay,
went wrong.
okay.
Oh, so it wouldn't be 40 take away 10x. It would be 40 take away 2x.
So 5 times this, 5 times 8 is 40. 5 times 2/5 x, the 5's cancel, the 5's dead. So the 2's left alive.
Okay.
Right? So you could, like I said, when we did this, like I said, you could totally multiply by 5 on this step to kill the fraction immediately. Right? You get large numbers, but at least the round numbers. So then if I subtract 40, divide by -2, what do I get? 15. Right? Of course I get the same answer because math doesn't care which way you do that. I multiply by 5 eventually in both cases, so it comes out the same answer. How are we doing so far? We all right? The thing I just don't want you guys... Again, there's more flexibility in some of the stuff we're doing, but if I start to show you everything, you start doing the wrong thing to it, like you think it's more flexible than it really is. So you could actually multiply 5 in here, but you can't do that with everything. I can't multiply a variable in there because the variable could be negative, for example. You can't subtract 8 out of there because it's stuck inside the absolute value. So that's why I just try not to even teach that at all. When you get further along, you start to do more flexible things when you're more used to it. All right. So that's the first problem. What about this guy? I mean, 4 minus 2 times what? What is this?
Absolute value.
The right answer is, I don't know. So I can say like 4 minus twice something plus 7 equals 1. How would you solve that equation? What would you do first?
Minus 4, minus 7.
Yeah, you subtract 4. All right, so I'm going to do the same thing here. I want to isolate this dude like it's its own little variable. Right? Do I know what that is? No, I want to get it by itself. Subtract 4, subtract 7. So what do I get over there? Yeah, -12. And then? Divide by -2. So let me bring it up here. So then I get 6. So am I allowed to keep going?
Yep.
Yes, cool. Came out positive in the end. So then I can say either
5 equals 6.
or
-6.
cool. I like it. So add 5, get 11, divide by 3, 11 over 3. Add 5, you get -1 divided by 3. Sweet.
So you gotta, you can't subtract the 2 from the 4 first.
Definitely not, because the 2 is involved in a multiplication. Multiplication comes before subtraction.
But you're not multiplying, correct?
Yeah, well, it wants me to.
Yeah.
So I can never do subtraction before I do multiplication in this kind of problem. Like, so if I had 4 minus 2 times 3, so what your point is, if I had 4 minus 2 times 3, what would I do first here?
2 times 3.
Exactly, and because, I would do it
Yeah.
because I can. But even if it's 4 minus 2x, can you make that 2x just because you can't do 2 times x? No, that's not like terms, right? So these are not like terms. Same thing, I can't put 4 ones together with 2 of these. They're not like terms, so that's why it's an equation, thank God, so what can I do with that 4 that I really want? I just get it out of the way. Right, that's the beauty of equations, just get that out of the way. I don't like fractions, alright, kill them. When you have an equation, you're allowed to do that, alright? Alright, did we finish? Yeah, we did, good. So here's a really good question to ask. Here's the last thing I'll show you about equations, then we've got to get into inequalities. What if there's more than one absolute value?
Order of operations, left to right.
We're talking about like absolute value plus absolute.
You ready? No. Can't do those. But what if I had absolute value of 2x minus 1 equals the absolute value of 5 minus x?
You'd set them equal to each other.
Yeah, what's got to be true about the 2 numbers? Give me 2 numbers I can put in there and make it true. Any numbers you want.
6 and 6.
6 and 6. What else would make it like related to 6? What else would work? Because what's the absolute value of 6? 6. What's the absolute value of 6? 6. So, or this could be negative 6 and this could be 6. Or this could be 6 and this could be negative 6. Or they could both be negative 6. So then you start to think that maybe there's 4 cases. But there ain't. There just is not. Alright? Because all this is really saying is either they're the same sign. You see that? Either they equal each other, right? Either this inside is the same as that inside. So those are the same case. Either those are equal. So how does that interpret here? Either 2x minus 1 is already equal to 5 minus x. And then, of course, the absolute values would be equal to each other, wouldn't they? 7 equals 7. So what's the absolute value of 7? It's the absolute value. They equal each other. 8, negative 8 equals negative 8. The absolute value of negative 8 equals the absolute value. Does that make sense? If these numbers already equal each other, then this is true. Right?
Mm-hmm.
Or one of them is the opposite of the other one. Or this one, maybe, is the opposite of this one.
Yeah, minus 5.
And I really want you to understand, the cases actually didn't change.
Same.
Well, how do we do it? What's how we always do it? We leave it alone. Or we put a negative on the sign. I mean, it's the same cases as before. Maybe. You actually do exactly the same thing you always do when there's 2 absolute values in there. You do the same thing you always do.
But then don't you
Try
like
to
plug
take a
in? Don't you plug in the answer? Because I already did the homework and there was a question just like it. And I think I got like.
Well, we don't have answers yet, so we can't.
No, I know, but I'm saying like, say if you got like, say if it was like negative 5 and then 5, but when you apply it, only 5 worked. So the answer would only be 5, right? Like say if the negative 5 didn't work. You get what I'm saying?
Sort of.
So you did that and then you did that.
The only way to get
So you come out
something, I'll show you an example that has only one answer. Right? But it's not because of what you're saying. You don't have to check them like that, to believe it or not. So let's do this one. This is going to come out with 2 answers, and then I'll show you one of these that only has 1 answer to it. Right?
Okay.
You alright? Sounded pitiful. So how do I solve this? Don't think it's too much. How do I
use add x.
Add 1, add x, right? 3x equals 6, x equals 2. Solve that. What do I have to do first here?
Distribute the negative.
Yeah, distribute the negative. And now you do the same thing. Subtract x, add 1, and get x equals negative 4. Sweet, here's my 2 answers. What?
Oh no, I did something wrong. I put a 3 there instead of a 2.
Right. That'll make it free. You guys with me on that? The place where people make mistakes, so this is the same place everybody makes mistakes with this kind of thing, is you forget to bring the negative through. You just write the second case like this, 2x minus 1 equals negative 5 minus x. Well, no, it's got to be negative this number, so the negative's got to go to both pieces of the number. Right? So the biggest mistake people make with that kind of thing is to forget to distribute the negative sign.
And if it were the opposite, switched over, 5 minus x is first, so 2x minus 1, it still would be the same way right now.
If I divide both sides by a negative, wouldn't the negative just show up there?
If you switch the two around, 5x
I know. So what you're saying is, if these were turned around, you would say 5 minus x equals negative 2x minus 1, right?
Right, that's what it is.
But see, if I divide both sides by a negative, don't I just get right back to there? These are the same exact equation. These are the same equation. Did I just blow your mind? These equations are exactly the same, because if I divide both sides by negative 1, what happens? These go away? Oh, let me do it this way better. This is a little bit easier to see. If I multiply both sides by a negative 1, what happens? I get negative 5 minus x equals, bam, bam, 2x minus 1, which is this equation. That's why there aren't 4 cases, because 2 of them are the same and the other 2 of them are the same case. Who cares if I put the negative on that side or I put the negative on that side? It's the same equation. It just says one is the opposite of the other. So that's why there aren't 4 cases, thank God. Right, so whenever you have an absolute value, there will always be just 2 cases. So let's see a real quick example where I get just one answer. Then we'll go a little bit further, then we'll take we'll finish out chapter 8. We'll take a break, and then the rest of the class will be devoted to review. Right? I forgot what the heck I was trying to do. I love it. The occasional sigh. Oh, math.
Oh, so we're not doing chapter 9, right? We're doing
Not today. We'll do it for the next test. So I'm not throwing out section 9.1. Don't get overly optimistic.
Wait, so that's not going to make it super hectic for next week, right?
No, I'm not going to allow that to happen.
Because we'll have the test and then we'll go over chapter 9.
So section 9.1 will be in the next test, so I'll probably have to shuffle a little stuff over. And I got some flexibility in later stuff too. So there are some sections I put down on our homework sheet that are actually kind of optional. I was just putting them down there just because I was optimistic.
Okay. I just didn't want it to
I'm
be
not
really
saying
hectic.
it's just, it depends on how things go. I can take some out if I need to, because there's nothing that I have to do. There's stuff that